Welcome. In this video, I'm gonna teach you how to find I'm gonna teach you how to determine whether a vector, in this case 2, 5, is a linear combination of 0, 1, and 2, 2. So we need to find whether a vector is a linear combination of other vectors. In this case, these are the vectors we're gonna be working on. So usually what this tells you is that we need to solve this system. Basically, we can write it as follows: 0, 1, 2, 2, and then x and y is equal to 2 and 5. So this is the system that we need to solve in order to find this answer. But when you're working with a vector of with just two variables, then it's kind of easier to do it as follows. In case, for example, you have a 3 by 3, then definitely you're gonna have to find the solution to this system using Gauss-Jordan method or elimination method or some other kind of method of solving a linear system. But let me show you the way I would do this type of example. So what I'm gonna do is I'm gonna write a linear combination of this vector in terms of these two vectors. So the way I'm gonna do it is as follows. So we're gonna do x. So I'm writing in vector form. Okay, so y 2, 2 is equal to 2 and 5. Okay, so now we have written a linear combination, and the answer to this question is that if we find x and y such that when we compute the left side it should give us the right side, then we do have a linear combination of vector 2, 5. So notice, what can I multiply 0, 1 to get a 3 here? If I let x equal to 3, this becomes 0, 3, and this is already 2, 2. So if I add 0 plus 2, I get 2. So basically y has to be 1. So if I let x equals 3 and y equals 1, then we have a solution. Let's do it. So something like this small, we can think about it. So let x equals 3. So for example, 3, 0, 1 plus 1 times 2, 2. That's equal to, so I distribute the scalar, so that would be 0, 3 plus 1. This becomes 2, 2, and that becomes 0 plus 2. That's 2, and 3 plus 2, 5. So we got it. We got the right side. So that means that we do have a solution to the linear system. When we have a solution, that means that we do have a linear combination. These two can form a linear combination to get vector 2, 5, and we prove it here. And the solution to that system is x equals 3 and y equals 1. I just thought about it because this is already 2, so what can I add to 2? to get 5. I need a 3. So what do? I multiply 3 times 1, and then 3 plus 2 equals 5, and then 3 times 0 is 0. So y has to be 1, because 1 times 2 is 2, 2 plus 0 is 2. That's how I figure it out. I just thought about it. But if you have like a 3 by 3, a 3 vector is kind of harder sometimes. So, or the more vectors you have, you probably need to use row reduced echelon form or other type of method to solve such linear system, because it's not going to be that easy. Thank you very much. Don't forget to subscribe, please.